Now give these problems a try before you continue the video. Now that you have tried these problems, we can look at the solutions together. And in order to write the vertex form from the graphs, we again want to start off thinking about where the vertex is in each graph. So in the first one, if we look at the vertex, it's right over here. And when we look at the scale, you can notice that x and y axes again have the same scale, and each box is corresponding to 1 unit. So we can identify the vertex coordinates to be -2, -5. And with a vertex given, we can go ahead and write out the vertex form to be a, which is a leading coefficient that we don't know yet, x minus h squared plus k. And since we have negative values, we can take a step to just simplify things a little bit, and we get a times x plus 2 squared minus 5 as a result. In the next step, we want to find what exactly the a value is equal to. Then your goal is again to find points on the graph that meets at the intersection of the grid lines. And we can see you can choose this point over here. Alternatively, I think you can choose this point and this point over here to be your point that you can use to identify the value of a. And here I'm going to use this green point, and we can identify the coordinates to be -1, -2. And that tells me when the output gives out -2, that happens when the input is -1. So therefore we get a times -1 plus 2 squared minus 5. And we can therefore have -2 equals, here -1 plus 2 is 1, 1 squared is still 1, so a minus 5. And to find a, we can add 5 on both sides and get a is equal to 3 over here. And our proposed solution for the vertex form is 3 times x plus 2 squared minus 5. And we can always check by using any of the other points. So for example, the one point we have on the y-axis is 0, 7, and we can check whether 0, 7 checks out for our proposed vertex form. So when the input is 0, output should be 7. That's what we want to check. So using the vertex form, if the output was 7 over here, we want to check whether this happens when we have the input equal to 0. And these are the values we focused on. Now on the right hand side, we have 2 squared, which is 4, so we have 3 times 4 minus 5. And if you calculate it, we can see indeed 7 is equal to 7. This checks, and we can make sure that we found the right point, we identified everything correctly. And sometimes the checking process is just helpful in case it's a little bit hard to tell which points are exactly on the grid lines. So it's good to have a second pair to double check whether your answer does work out with a graph. And now with the information here, we can move on to part B. In part B, we have a similar scenario. We can start off with calling this being g of x, and we don't know what the leading coefficient is yet, and we want to find h and k values from here, from the vertex. And if we look at the vertex in this case, this on the x coordinate, we have this on the grid line, but on the y direction, I think it's exactly halfway in between the two grid lines. And for the x coordinate, we can see every 5 boxes is corresponding to 20, so that means each box is corresponding to 4 units over here. And that tells me this x coordinate has to be -4. And on the y direction, if we have exactly the same scale, that means every box is corresponding to 4 as well. And if it's halfway, that means it's -2 as a coordinate. So we can again plug -4 and -2 into the vertex form. Simplifying this gives us a times x plus 4 squared minus 2. And using this, we can go ahead and find another point in order to find what exactly a is. So in this case, we can find a using these 2 points, or one of these 2 points, or I believe there's another point over here. These 2 points would also work over here. And with this information, we can go ahead and try to identify what the a value is overall. Here, if we identify the points, this is going to have the coordinates being 0, negative 12. And we can use that information to plug in, and g of x would be equal to negative 12 when we have x is equal to 0. So this is a times 0 plus 4 squared minus 2. And altogether we should have negative 12 is equal to 16a minus 2. And to simplify it, we can add 2 on both sides and get us negative 10 equals 16a. So a is equal to negative 10 over 16, or we can reduce it to get a is equal to negative 5 over 8 in this case. So our proposed solution is going to be g of x equals negative 5/8 x plus 4 squared minus 2 in this case. And we can check our answers using the other point over here. And the other point is negative 8, negative 12. So if we want to check, we can go ahead and use negative 12 to see whether that's equal to negative 5/8 times x, which is negative 8 again, plus 4 squared, and minus 2. So if we simplify it, we would get negative 12. On the right side, we have negative 5/8 times negative 8 plus 4 is negative 4. Squared will be 16 minus 2. So there's a little cancellation. We get 2 over here. And if we simplify it, we can see negative 12 is equal to negative 12 on the right hand side. So we know that this is going to be our vertex form for the graph that we're given in this case. And to identify something in the vertex form, the key point is a vertex. And using this information, we can pick any other point on the graph to find out what the leading coefficient is equal to. And that's a general process to find it.